Good afternoon, thank you. So my name is Estefania Imbachi, as Dr. Collins just said. I'm from Colombia, I'm chemical engineer from Colombia, and I work almost 4 years in the sugarcane research center in Colombia. So then I work almost 2 years in a sugar factory. And now I've been here at Audubon Sugar Institute for almost 1 year. And now I'm going to here to present how a 4 year review of a sugarcane factory data can help you. So I just want to make sure, can you see my screen? So daily information from 4 grinding seasons between 2015 to 2019 for one Louisiana factory were analyzed to identify operational problems in different production areas, as well as improvements and outstanding performance in specific unit processes. So I was saying, so daily information from one sugar factory were analyzed to identify operational problems in different areas and to identify improvements or outstanding performance in specific unit processes. So we analyze different variables such as pulp, purity, bricks, flow rates, among others. And we use a statistical analysis. So we use Pearson correlation coefficients, p-values, and the normal statistical analysis that include means, the standard deviation, maximum and minimum values. And we also estimate sucrose losses across the factory in some specific areas. And we use the two formulas that you can see here, one based on the increase of glucose and the other based on the reduction of sucrose. So the common factory methodology that this factory in a specific use is just to graph some of the information that daily obtain. So the factory's laboratories daily analyze hundreds of samples. They analyze juices, syrups, molasses, masquid, among others. But most of this information is not adequately analyzed. So they just obtain hundreds of samples of data like this in tables, but they don't analyze that properly. So the maximum that they can do is graphs like this. Not only because they maybe don't have the resources, because they don't have time to do it. So I think, sorry.
Yeah, go to the next one.
No.
It's not advancing.
Avery, can you share the video when you're in?
And yeah, she'll just tell you when to
Yes,
advance it.
yes, I can. Let me do that real quick. Continue. Share. And can everyone see that?
Yeah, we can. Can you see it, Stefania?
She's
Stefania?
muted.
Oh, she's muted.
Yeah. Can you hear me?
Yes.
Okay.
Just tell me when to advance, Stephanie.
Okay, go to next, please. Yeah, that's it. So here we are using two methodologies to analyze the information. So the first one that we were using is the box plot. It's a method for graphically show groups of numerical data through their quartiles. So box plot may also have lines extending from the boxes. So this is the box, and those are the whiskers that shows the maximum and minimum values. So this point here shows the maximum value of this variable. This the point at the bottom is the minimum value. It also shows the top of the box is the 75 percentile. The median of the box is represent the median value of the variable, and the top of the box shows the 75% of the variable. So on the right side, you can see an example of one variable. So we analyze that variable in 2 different years, year 1 and year 2. And you can see that the variable in the year 1, the box is a little bigger than the box on the year 2, which represent that the variability of this parameter during the first year was higher than the variability of the same variable on the second year. So this is just a graphical method to help to easily compare the behavior of variables during the time or during different grinding season. Next one, please. So the second methodology that we use is the histogram. It's a frequency distribution that shows how often each different value in a set of data occurs. So for example, this is the juice pH frequency diagram. So let's say your target for the juice pH is 76.9. So that means that 28% of the data of the juice data had that pH at that time. So with this, you also can see the variability of this kind of parameters. Next one, please. We analyze different process units in the factory. The first operation unit that we analyzed was the storage of cane. So we know that most of the factory, all of the factories here in Louisiana storage cane during the night, and then in the next morning they grind that cane again. So in this specific factory, the delivery of fresh cane to the factory begins after 3 a.m. However, the factory estimate that they start grinding fresh cane only after 11 a.m. And with this analysis, we confirm by a statistical analysis that the cane suffer a deterioration during this time, and the juice purity is higher after 11 a.m. when they start grinding fresh cane. You can see in the boxes for each year that between 11 a.m. and 11 p.m. the purity of the juice is higher than the purity at 7 a.m. and 3 a.m., which are the first and the last one box in each set of boxes. So juice purities were statistically lower at 7 a.m. and 3 a.m. when the stored cane was still being crushed. And juice purity at 7 a.m. could be higher if the factory could use FIFO methodology. So what is FIFO methodology? FIFO methodology is first in, first out. So we know that the factories storage cane during the night, and they put like the cane at 7 p.m. they put it in a place, but they are going to start grinding that sugar cane the next morning. And the last cane that they put it in the ground, let's say 6 a.m. is going to be the first one that they are going to grind the next day. And it should not be like that. It should be in the opposite way. If the first cane that they put in the ground should be the last one that they have to take. Next one, please.
The video.
The next unit process that we analyze is the milling process. So a pulp extraction greater than 96% is expected in the milling process to obtain a pulp in bagasse under 2 points. However, the pulp extraction obtained since 2016 was below 96%. You can see that in the graph on the left. Therefore, the pulp in bagasse was about 2 points, and you can see the pulp in bagasse on the graph on the right side. There was a reduction in the pulp in bagasse values between 2015 to 2019, but from 2.6 to 2.1, which could also be affected by the reduction in pulp of cane in recent years. The next station is the use clarification. So this factory has 3 clarifiers operating in parallel. We compare the performance of each clarifier, and there was no statistical difference in the performance of each one for each year. Another thing that we analyze here is that it was notable the effect of the juice pH on the turbidity of the clear juice. You can see on the right side on the slide, in 2016, the target pH for the juice was around 7 to 7.2, and only between 35 to 45% of the juice had that pH at that year. And on the left side of the slide, you can see the clear juice turbidity. And specifically during these years, 2016, you can see that the turbidity, the boxes of the clear juice, is bigger than the other boxes of the other years, which means the pH it was affecting the clear juice turbidity. If you go to the graph on the right side, on the bottom side of the presentation, you can see the histogram of the pH, but in 2019. And you can see that the control of pH improved, because now between 70 to 82% of the juice had the correct pH between 7 to 7.2. So why this control pH improved? Because the factory started a strict electrode cleaning routine, and they also installed a pH meter with higher resistance to falling juice conditions. With this improvement in the control of the juice pH, they improve also the turbidity of the clear juice. So if you see the box plot, you can see that during 2019, the box plot are smaller than the other years. So an improvement in the control pH improved the clear juice turbidity also. Next one. The next station is mud filtration. So this factory has five filters working in parallel, and the stability of the filter cake has improved over the years. You can see that the box, you can see on the left side of the slide, that during the 2015 and 2016, the variability and the size of the box was higher and the whiskers. But at the end, during 2019, the box was a little small, and the whisker also were shorter. So that means that the stability of that variable filter cake pole improved during the years. If we are going to analyze the capacity of this station, we analyze the meter square per ton of cane per hour. As a general standard, we can say that a factory is going to have a low filter cake pole if this value is between 0.5 to 0.7. So that means that the factory has enough capacity to process the mud. In this factory in particular, the capacity is around 0.4, which is below the recommended standard. So this factory knows that they have to work in this area, and they are planning to install a new mud filter to increase the capacity. And due to this short capacity, they have to increase the speed of the bigger filter that they have, the filter 1 and the filter 4. And you can see that the result of this is an increase on the pole of the filter cake. So in the graph in the middle, you can see the filter cake pole per filter, and you can see that the filter 1 and the filter 4 has the higher pole. The next station is evaporation. So this factory has three sets of evaporators working in parallel, and we compare the performance of each set of evaporators. And we didn't find differences between the three sets. The bricks in each one is almost the same. However, it was a difference between the operation hours in this factory. So in the table, you can see the final evaporator syrup bricks at different times. So you can see the bricks between 7 a.m. to 3 p.m. and the bricks between 7 p.m. to 3 a.m. And in each series, in each set, you can see that during the day, between 7 a.m. to 3 p.m., the bricks is lower than the bricks during the night. So we asked to the factory why this could happen, and they told us that during the day they have to clean evaporators. So the area is lower during the day, and that obviously is affecting the syrup bricks. In this area, we also analyze the variability or the stability of the syrup bricks at the end of the evaporation process. The target for this factory for the syrup bricks is between 63 to 64. And during 2018, 23% of the syrup that they were producing had the correct bricks. And then in 2019, that stability of this process improved, because now 53% of the syrup had a correct bricks. So the factory makes some improvements in the evaporation station. One of them was they started using a heat transfer coefficient as a measure of the efficiency of the evaporation station. This is one of the tools that Dr. Birkett helped them to install in the factory. And among others improvements, they increased the efficiency of this station. That's why we are seeing a better control in this station between 2018 to 2019. In the final unit, in the boiling house, we analyzed some of the variables that you are seeing in the table. So the mass quid purity and the crystal content in CPAN during 2019 were between 53% and 28% respectively. According to those values, the purity drop in CPAN should be 20 percentage points. But as you can see in the table in the red square, you can see that the CPAN purity drop that the factory obtained was between 12% with maximum values of 16%. So they have like a low efficiency here, sorry. So this indicates a low exhaustion in the CPAN, which could be a result for a small amount of seed, a small seed crystal, short boiling or crystallization time, among other factors that could affect the efficiency in the CPAN. So we are going to work with this factory to try to figure out which of those factors are affecting the CPAN efficiency. So the results that I already showed you are just some of the results that we obtained for this analysis, but here I'm going to show you all the conclusions that we got. So the crucial use purities were statistically lower at 7 a.m. and 3 a.m. when the cane store was still be grounded. The factory should use FIFO methodology, so remember first in, first out. The pole extraction in tandem mill was below 96%, so the factory should work in this area to improve the cane preparation in order to reduce the polling bagas below 2 points. The imbibition was between 200 and 250%, with a notable decrease in the deviation since 2015. However, it's recommendable to keep the imbibition as lower as possible if the factory wants to increase the milling rate without increasing the capacity, or in case that the factory has problem with the steam availability. Since 2015, the maximum purity drop in the tandem mill was 1.4%, which was a result of the cleaning practices in the tandem mill in this factory, because they use shot treatments with bleach, and they also use hot water to clean the mills. The use clarifications in the 3 clarifiers can be rated as satisfactory, with turbidity in clear juice around 10 units, and we didn't found any differences between the 3 clarifiers that they are using. After 2018, the factory improved the control of the juice, of the pH of the juice. So the clear juice pH data between the target range increased up to 87% and 82%. The filter capacity was around 0.4 meters square per ton of cane per hour, less than indicated by references. So that low capacity increased the speed of the filters 1 and 4, which increased the pull in the filter cake. From 2019, there was no statistical difference in the syrup bricks produced in the 3 evaporator sets. However, we found a difference in between the the syrup breeze during the day and during the night. The purity drop in C-pan reach was 12% below the reference of 20%, which, as I say, they have to find which factor is affecting this low exhaustion. It was found that sugar reducers, ash, C-mass with viscosity, and C-magma purity affected the final molasses purity. However, the multiple correlation coefficient was 74%, which suggests that other components, it could be fructan, dextran, or different components, could have a greater role in the final molasses purity. And finally, I just want to say that Audubon Sugar Institute is willing to provide factory data analysis for the Louisiana sugar factories, following the methodology that I already explained. And if you need more information, please contact me. That's my email. And we are able to analyze information that you have from the last grinding seasons.